everyone, this is Mrs. Musoff. Today we're going to keep talking about logarithms, but now we're going to get into some properties of logarithms. And when it comes to these properties, the most important thing to remember is that logarithms are related to exponents. Because they help us solve problems or equations like this, where the variable is in the exponent. And the reason that's important to recognize is because the properties of logs are pretty similar to the properties of exponents that we learned at the beginning of the semester. For example, if we had two bases multiplying, like x to the fourth times x to the eighth, we would add the exponents, right? It would turn into x to the 4 plus 8, which is x to the 12th. Alright? Those two operations, multiplying and adding, they go together when it comes to logs too. So that's why we expand multiplication into addition when we use logs. So for example, if I had something like log base b of x times y, alright, so if there was multiplication inside, I can expand it into addition. So log base b of x plus log base b of y. So each thing you're multiplying gets its own log, and you just turn the multiplication into adding. Alright? And again, that comes just straight from our exponent rule. And same thing for our second property. If we had two bases dividing, like x to the fifth divided by x to the third, we would subtract. Right? It would turn into x to the 5 minus 3, which is x squared. Well, that's why we expand, that should say dividing. Alright, that's why we expand dividing into subtraction when we use logs. So, if I have one log, and inside there's dividing, x divided by y, I can expand it out, give each thing inside its own log, but turn it into subtraction. Alright, and then our last property comes from when we have an exponent with another exponent. So if we have x squared to the fifth, so two exponents, we would multiply. Alright, so when you take it to a higher power, you multiply. Alright, and we do this with logs also, so that's why we pull down the power and multiply it to the outside. So it would look something like this. Log base b of x to the n. I would take that exponent, that power, and I would move it to the front and multiply. So it would be something like this. Alright, and those are our three properties for logs. So hopefully they're easy to remember because they're really similar to our exponent properties. But the more you practice it, the better you'll remember it. So let's try a few examples together. Alright, in these they say expand the expression. When we think of expand, that means make bigger. Alright, so whenever I see the directions say expand, that means you want to expand it into multiple logs. So you're not just going to have one log, you're going to have a few of them. Alright, what I like to do is I like to look at the log and first figure out how many logs you're going to have. And the way you can tell that is based on how many factors there are in your log. So like right now, this is what's inside my log, and there are two factors, two things you're multiplying. There's a 2, and there's an x to the 6th. That's all one. That x and the 6th, they go together, because one can't exist without the other, right? So they go together. So because I have two pieces, that means I'm going to break this log up into two logs. So I'm going to have a log base 5 of 2 and a log base 5 of x to the 6th. And since it's multiplication, multiplication always turns into addition, so I would change that to addition. Alright, and that's step 1. So step 1 is always to figure out how many factors there are so you know how many logs to write. Okay, so I'm just going to write over here step 1. Step 2 is going to be to take any exponents that you see and bring them to the front and change it to multiplying. Alright, I don't have an exponent here, so I'm going to leave that one as is. But since that second one has an exponent, I'm going to bring it to the front and turn it into multiplying. So 6 times log base 5 of x. And that would be it. I'd be done because they're separated and there's no more exponents. Alright, let's try it again. So in letter B, same idea. Alright, step 1 is going to be to figure out how many logs I need. So I'm going to look at what's inside my log, so that's what I just put in parentheses. There's a y on top, there's a 3, and then there's an x squared. Make sure you remember to separate the numbers from the variables. So like that 3, that coefficient, gets its own log, and the x squared gets its own log. So there are going to be 3 logs in this one. Alright, log base A of y, log base A of 3, and log base A of x squared. To figure out whether it's addition or subtraction, I'm going to look and see which side of the fraction they're on. So the ones on top are going to be addition, and the 2 on the bottom, since they're being divided, dividing is always going to be subtraction. Oops. Alright, so subtraction for the 2 on the bottom. Okay, this one's positive because it's on top, but these 2, since they're both on the bottom, it's subtraction. Alright, and then our second step is going to be to take any exponents we see and move them to the front. Become coefficients. So, no exponent in the first one, I'll leave it. No exponent in the second one, so I'll leave it. But that third one has the 2, so I'm going to bring it to the front. Turn it into multiplication. And there's our final answer. Okay, let's try it again in letter C. So, letter C, same thing. The first thing I'm going to do is look inside my log and figure out how many logs I'm going to expand this out into. So there's a 12 to the 5/6, and there's an x to the 9th. So each one of those is going to get its own log. So it'll be log base 3 of 12 to the 5/6, and log base 3 of x to the 9th. And then once again, step 2 is going to be to take those exponents and bring them to the front. So I see an exponent right here, so that's going to go to the front. And I see an exponent right here, and that's going to go to the front. Whoops, I almost forgot. Is this going to be addition or subtraction? Well, right here it's multiplying. Multiplying will always turn into addition. My fault. Okay, but now I am going to do those exponents, so it'll be 5/6 times log base 3 of 12 plus 9 times log base 3 of x. And that'll be my final answer. Okay, another one on this page, so letter D, again, look at what's inside your log and try to figure out how many factors there are so you know how many logs to use. I see a 6, an x cubed, a y, and a z. 4 factors means 4 logs. So for step 1, I'm going to split this up into 4 logs. Now notice how this does not have a base. That means it's a base 10. You could write it in there, or you don't have to. It really doesn't matter. So I'm going to have a log with the 6, a log with x cubed, a log with y, and a log with z. And if it helps you, go ahead and write those little base 10s in there. That way you're not confused when you don't see a base. Okay, and then in terms of whether it's addition or subtraction, these are all being multiplied because they're all next to each other, right? That's multiplying. So it's all going to be addition. Okay, the only time you'll have subtraction, just in case you didn't notice, is when you see something like this where there's a denominator. Denominators mean subtraction. All right, we didn't have any in those other 3, but you can see that one as the example. Okay, and then step 2 is to find any exponents. I only see one exponent, so that's the one I'm going to bring down. Everything else will stay the same. So log base 10 of 6 plus 3 times log base 10 of x plus log base 10 of y plus log base 10 of z. And there's my answer. Alright, go ahead and flip it over. Let's try just a couple more. Alright, every so often in the expanding ones, you're going to see one of our special logs, like this is a natural log. No big deal, nothing really changes. We're still going to do the same steps. So I'm going to look at what's inside my log, figure out how many factors I have, 11x y squared. So that's 3 factors, that means 3 logs. Just this time they'll be natural logs, so I'll write ln. So it'll be ln of 11, ln of x, and ln of y squared. And once again, since these are all being multiplied, these would all be addition. Alright, and then step 2, find any exponents and bring them to the front. Only one exponent, so everything else is going to stay the same. 2 times the natural log of y. And there's my final answer. Alright, let's try one more with that denominator so you can kind of see the difference between these things, when there's a denominator and when there's not. Alright, so step 1 and step 2. So step 1, once again, I'm looking at what's inside my log, trying to figure out how many factors there are. So there's a 4, an x squared, and a y cubed, so that's 3 of them. So I am going to make 3 log base 2's. So log base 2 of 4, log base 2 of x squared, and log base 2 of y cubed. Now, again, everything on the top is going to stay positive. So the log base 2 of 4 is a positive. This x squared, that'll be plus. But the y cubed, since that's on the bottom, that's going to be a minus sign. Alright, so again, those top ones is multiplying, but the bottom one is dividing, so that's why that turns into addition, and that turns into subtraction. Alright, and then once again, any exponents that we see, we're going to move to the beginning to multiply. So log base 2 of 4 plus 2 times log base 2 of x minus 3 times log base 2 of y. Okay. Now, some of your teachers might ask you to keep going. And you might say, well, wait a second, all the other ones only had 2 steps, how can I keep going? Well, there's something kind of special in this one that allows you to keep going, and it's this piece right here. Alright, think back to when we were doing logs in the last couple days of notes. Alright, we said that a logarithm is really an exponent. So what this is really saying is 2 to the what exponent would give me 4. Well, since I know that that answer is a whole number, right? I know that 2 squared would give me 4. That means that I can simplify this entire expression. Log base 2 of 4 is actually, the answer to that is just 2. So I could rewrite this and just say this is going to turn into 2, and then everything else stays the same. Okay. Some of your teachers might not make you do that, so you can ask your teacher to be sure. But just to show you that you could simplify that in this problem. In these other problems we did, like natural log of 11, I can't do the same thing. And like log base 10 of 6, 10 to the what equals 6? I don't know the answer to that, right? So that's why we can't always do this extra simplifying. But when it's possible, sometimes you'll notice that we like to try and simplify. Alright, that's all for today's video. If you have questions, write them down, and be sure to ask your teacher in class. Thanks for watching.